Welcome to PeopleTools Tech Tips. I'm Randy Groncki. Today we're going to create an XML file using PeopleCode's XMLDoc object. PeopleCode's XMLDoc was developed to work with external XML file sources, whether they were coming in or going out of PeopleTools. The premise for this is to create an XML file for a BI publisher, but using XMLDoc, we can use it any way we want. The general idea is grab your data, load up your data, and get some kind of structured method. Then we're going to use that data to go and create our XMLDoc using the structure of our source data to create the structure of our XMLDoc. Then we're just going to export that out into an XML file, and then we can use it for whatever we like from there. So, use an XMLDoc. Why do we use an XMLDoc? Well, it's very powerful and we can manipulate it in a lot of ways. This video is not going to cover all the properties and methods of the XMLDoc. There are a lot of them. We're just going to be using it to take our data and export it to an XML file the way we want. Especially for BI Publisher, why use an XML file versus PS query? Well, XML file is a whole lot more efficient, it's more secure, it's better, faster for your BI Publisher on the other end. As far as using XMLDoc for external files, you have the ability to create the structure that you need as far as the other system's specifications to a high degree. This is a whole lot like freeform creating the XMLDoc from just texting and hammering it together using concatenation. However, XMLDoc is going to take care of the XML structure for us. We don't really have to worry about parent-child, NDocs, NXML, and all that stuff. XMLDoc will take care of that structure for us and keep us correct inside the XMLDoc. So the first part of this video is a section we've used before about creating the data set for our XMLDoc. So that's going to be just a few minutes there. Forward on to this point to see the actual XMLDoc, taking that structure into the XMLDoc as far as creating and putting it out. Once we have our XMLDoc, we're going to write the file, we're going to put it up there. So let's start with creating our data set and creating our XMLDoc. Let's take a walkthrough of what will be our final solution. Go to our work page and click on the XMLDoc button. The XML file is generated and popped up into a new tab. We show our XML string on the page, also showing our fully qualified file name for our generated XML file. Looking at the log file utility, we see our XML file in the default files directory. The PeopleTools project and all demonstration objects and code is available at PeopleToolsTechTips.com. It's all free to use and review. We won't make you sign up for anything to download. This is our app package that generates the data for our example. We have used this for several demonstrations so far. This loads and creates a parent-child rowset with basic employee data and that employee's training records for a letter or report. Let's take a look at load test data. The class is a constructor, but the constructor does nothing. The heart of the class is the load test data set method, which returns a rowset, not a string, but a rowset. The load employees image method is for a later episode where we will show you how to put photos into rowsets as base 64 strings and push them into a BI Publisher report. But not yet, stay tuned. Looking at the load test data set method, our variables, our records we are declaring. We are going to do one of the great things we can do with a rowset as a data source, enriching the data after the initial pull. This is much better than PS query where we'd have to get all the data in one huge bite. We select our main data and then enrich that data using smaller targeted updates. This is faster and much more efficient than PS query. Here we are creating our complex rowset. With a parent-child rowset, start by creating the child rowset and then create the parent rowset with the child rowset as a parameter. We fill the rowset because it's a created rowset, not from a component. We are filling the parent rowset with all the employees whose employee ID starts with KU00 and has training. Now that we have the parent rowset filled, we loop through each row and populate the child rowset for that row where the child employee ID equals the parent row employee ID. This is the employee's training records. Here's the cool stuff just to show you some examples how we can enrich the data. These may not be the best examples, but they show the concept. get data per each record row, and populate the detail where it's significant. Here we are getting the job information for that employee. Here we are getting the location information for that employee. We are using a location table, putting the key data from the job, and selecting by effective date. We set our location description to the description from the location table. Here we are getting company information from the company table. We are setting our company description to the correct description from the company table. Last, here we are getting the job code information for that specific employee. We could have pulled these values from a massive PS query with multiple table joins. However, I want to show you how we can do it here quicker and more efficient while not bogging down the database with an inefficient single PS query. You don't have to try to eat the whole elephant in one bite. The last thing we do is return our enriched row set. Let's start building this. The way we are going to do this is to first build the structure of the XML file and then populate the structure with the data. Import our load test data app package. These are the variables we will be using. The deskrelong field from the page is where we will be displaying our generated XML string. The file name field is where we will show the fully qualified file name to the file we create. Instantiate the load test data object, then fill our row set, now we have all our data. Next, create our XMLDoc object. The root XML tag is the parameter. Let's see how much just that does. Populate our string with the XML from the XMLDoc GenFormattedXmlString method. Now we copy that string to the deskrelong field on the page. Save. And test. We have the root of our XML file. We know our data structure. This record is the parent record. That's the child record. This is the employee data. This is the training data for that employee. We will loop through the parent row set and get all the employee records. One record per employee, and just put that into the file right now. Loop through the employees. We get the rows per each employee. Here is where we're going to create the level 1 nodes in the XMLDoc. One node per employee. This is the XMLDoc. Document element. Add element. Name the node employee data. Save. For every row, we have employee data. Test. Multiple rows of employee data. These represent all employees. Now we add the structure for the classes for each employee. Get the row set with the training from our parent row. For every employee, we pull the child row set of training out. For each row of training, we will create a new node, mid node, equals row node. Add element, name that child node training data. Save, test it out. For every employee data, we have at least one training data tag. Now, let's start filling the information about the employee. We're going to go through each field of that parent row record and then each field as a node with a value. Get the parent row out of the parent row. loop through all the fields in that record, add a child node. Child node equals row node add element. We're going to call this element the field's name. Child node value equals the field value cast to a string. Save, test. The employee data is in the XML file. Now to populate the training data for each employee. The mid node is the training node. Pull out the training node from the rowset row. Loop through all the fields of that record. Again, use the child node equals mid node add element. Name that element the field's name. Child node value is the same field's value cast to a string. Save, test. Now we have all our data. Training, course information. The next step is to put this string into an actual file. Instantiate our file. Default file path is relative. Remember to use character set UTF to not run into issues with characters and ASCII. Use the write line method to write our string to the file. Before closing the file, get the fully qualified path to the file in the file object's name property. Then close the file. Now we will copy the string to the fully qualified file name to the file name on the page. Save, test. There is the fully qualified file name and the XML data on the page. Verify that the file is actually on the server. There is the XML file we just created. Last thing to do is to pop this file to a new browser tab. I used the put attachment function to copy the file to an attachment table. Do save now to clear the think time functions. Then the view attachment function will pop that file to a new browser tab. Save, test. Here's our file in a new browser tab, the XML string and the fully qualified file name. And the new version of file is on the server. So we created a data set. Using that data set, we then used an XMLDoc object to create the XML file, and now we can do whatever we want with that XML file. Thank you for watching. Please consider subscribing to our channel, like and comment below. And we'll see you next time here on PeopleTools Tech Tips.